All right, everybody. Now, today is going to be sections 1.2 and 1.3. 1.2 is the handshake. 1.3 is make me an offer. Okay? So 1.2 has a restatement of all our problem-solving techniques that we use with Wild About Harry. So take a few minutes, review those before you continue with the video. Okay? So take a few moments and pause. Okay, welcome back. Now, the thing about this next section, the handshake, is you're going to actually shake everybody's hand in your group. We may even go as far as the class. We'll see what happens. Now, we're looking at types of sequences when we do this kind of thing. Now, there are two kinds of sequences here. We have arithmetic and geometric. So, arithmetic. This is something you want to write down in your notes. This is the definition, okay? We list numbers in consecutive order. That means one after another, okay? That follow suit, 1, 2, 3, 4, okay? That kind of thing, all right? So we're going to list our consecutive numbers, and they share a common difference. So, for instance, if I'm going 5, 10, 15, 20, what is the common difference there? Think about that and write it down. Okay, so you should have written down 5. 5 is the common difference between 5, 10, 15, 20. Okay, you go up in increments of 5. All right, so that is an arithmetic sequence. So let's look at this example here. We have 1, 4, 7, and 10. What is the arithmetic difference for these numbers? Three should be your answer, because there's 3 between 1 and 4, 3 between 4 and 7, 3 between 7 and 10. Okay? Now, what about 10, 50, and 90? This is a little bit shorter. However, there is an arithmetic difference. And your answer should be 40. Okay? Again, those are the kinds of things I want to see in your notes when you come into class. Okay, so the geometric sequence. Arithmetic, think about that, addition, subtraction, okay? Geometric is where we're doing the multiplication or division between numbers, all right? So make sure you have this definition in your notes as well. All right, so if I look at 3, 9, 27, 71, what do I do with these numbers? Well, 3 times 3 is 9, 9 times 3 is 27, 3 times 27 is 71. Verify that. I may be wrong. Okay, so check that. All right, so the geometric difference in this case is 3. All right, so this one, 1, 2, 4, 8, 16. The geometric difference would be 2. Okay, so keep that in mind for the 1.2 handshake. Okay. Next, we have inductive and deductive reasoning. This is introduced in the 1.3 Make Me an Offer, okay? So, with inductive reasoning, we look at patterns, things that happen, and then we can conclude, oh yeah, it's going to do this. So, for example, if I'm looking at the sun rising, okay, I go to the beach, I watch the sun rise, and it's rising in the east. And then the next day I go, and again, it's rising in the east. The next day I go, and again, it's rising in the east. So here it is. I can make a conclusion that the sun is always going to rise in the east. And that's because I went and found a pattern. I see what's happening. So with that, I can conclude the sun's always going to rise in the east. Okay? Deductive reasoning is a little bit different. You actually have to be able to prove it, okay? You actually have to have evidence to make deductive reasoning happen, okay? Deductive, detective. Think of it that way. When you're dealing with deductive reasoning, you're like Sherlock Holmes or any of the modern day type murder mystery people, okay? So like the guys in Numbers or the guys in, Criminal Minds or stuff like that. Think of it that way. deductive reasoning, you have to have the evidence to come to a conclusion, either true or false, all right? Keep that in mind, okay? The next thing in 3, formulas, okay? These are ways to represent our relationships. Common formulas that we have used in algebra would be your slope formula, right? Y equals mx plus b, that's your point, that's your slope-intercept form. That in and of itself is a formula, okay? Another common formula would be something for the area of a rectangle, okay? So if I have a rectangle, let's just make a rectangle here, all right? I have on the side here, the shorter side we always call the width, and the longer side we always call the length. Okay, that's a small L, guys, all right? So the formula for the area of a rectangle would be the length times the width, all right? So that is a formula. So if I give you that the width is 7 and the length is 10, to find the area, you would plug those in and find that the area is 70, okay? So formulas we use to represent information again. And of course, we usually plug numbers in to find a value. But again, we have to make a complete sentence to make these numbers make sense, okay? So take a look at some formulas, come up with a couple of them that you know, and bring them into class, and we will share them and determine whether or not we can use them in the problems that we are going to be using ahead, okay? So take a look at that and bring in your notes and bring in questions. See you in class.